In computer science, object composition is a way to combine simple objects or data types into more complex ones. Compositions are a critical building block of many basic data structures, including the tagged union, the linked list, and the binary tree, as well as the object used in object-oriented programming. A real-world example of composition may be seen in the relation of an automobile to its parts. Specifically, the automobile has or is composed from objects including steering wheel, seat, gearbox and engine. When, in a language, objects are typed, types can often be divided into composite and non-composite types, and composition can be regarded as a relationship between types. An object of a composite type has an object of a simpler type. Composition must be distinguished from subtyping, which is the process of adding detail to a general data type to create a more specific data type. For instance, cars may be a specific type of vehicle. Car is a vehicle. Subtyping doesn't describe a relationship between different objects, but instead, says that objects of a type are simultaneously objects of another type. In programming languages, composite objects are usually expressed by means of references from one object to another. Depending on the language, such references may be known as fields, members, properties or attributes, and the resulting composition is a structure, storage record, tuple, user-defined type, or composite type. Fields are given a unique name so that each one can be distinguished from the others. However, having such references doesn't necessarily mean that an object is a composite. It is only called composite if the objects it refers to are really its parts, that is, have no independent existence. For details, see the aggregation section below. UML notation. In UML, there are two ways of modeling composition and aggregation. Beware that in UML composition has a more narrow meaning than in ordinary language. Composition is depicted as a filled diamond and a solid line. Composition is a kind of association where the composite object has sole responsibility for the disposition of the component parts. The relationship between the composite and the component is a strong Euro-OEHAS or Euro relationship, as the composite object takes ownership of the component. This means the composite is responsible for the creation and destruction of the component parts. An object may only be part of one composite. If the composite object is destroyed, all the component parts must be destroyed. The part has no life of itself and cannot be transferred to another object. Composition enforces encapsulation as the component parts usually are members of the composite object. The more general form, aggregation, is depicted as an unfilled diamond and a solid line. Aggregation is a kind of association that specifies a whole-part relationship between the aggregate and component part. This relationship between the aggregate and component is a weaker Euro-OEHAS or Euro relationship as the component may survive the aggregate object. The component object may be accessed through other objects without going through the aggregate object. The aggregate object does not take part in the life cycle of the component object, meaning the component object may outlive the aggregate object. The state of the component object still forms part of the aggregate object. The image below shows both composition and aggregation. The C++ code below shows what the source code is likely to look like. Composite types in C. This is an example of composition in C. In this example, the primitive types int, char, and enum they, she, he are combined to form the composite structure person. Each person structure then has an age, name, and a pronoun they are referred to by. Recursive composition. Objects can be composited recursively with the use of recursive types or references. Consider a tree. Each node in a tree may be a branch or leaf. In other words, each node is a tree at the same time when it belongs to another tree. One implementation for the recursive composition is to let each object have references to others of the same type. In C, for example, a binary tree can be defined like: if pointers left and right are valid, the node is thought to be a branch referring to each tree to which left and right point. If not, the node is a leaf. In this way, the recursion can be terminated. Another is to use a tagged union. For example, C tagged union. Timeline of composition in various languages. C calls a record a struct or structure. Object-oriented languages such as Java, Smalltalk, and C++ often keep their records hidden inside objects. Languages in the ML family simply call them records. COBOL was the first programming language to support records directly. ALGOL 68 got it from COBOL and Pascal got it, more or less indirectly, from ALGOL 68. Common Lisp provides structures and classes. 1959 COBOL. 1960 ALGOL 60, arrays were the only composite data type in ALGOL 60. 1964 PLI. 1968 ALGOL 68. For an example of all this, here is the traditional linked list declaration. Note that for ALGOL 68 only the new type name appears to the left of the equality, and most notably the construction is made a euro, and can be read a euro from left to right without regard to priorities. 1970 Pascal. 1972 K and RC. 1977 Fortran 77. Fortran 77 has arrays, but lacked any formal record structure definitions. Typically compound structures were built up using equivalents or common statements. 1983 ADA. 1983 C++. 1991 Python. 1992 Fortran 90, arrays and strings were inherited from Fortran 77, and a new reserved word was introduced, type. Fortran 90 updated and included Fortran 4's concept called Namalist. 1994 ANSI Common Lisp. Common Lisp provides structures and the ANSI Common Lisp standard added CLOS classes. For more details about composition in C++, see composite type. Aggregation. Aggregation differs from ordinary composition in that it does not imply ownership. In composition, when the owning object is destroyed, so are the contained objects. In aggregation, this is not necessarily true. For example, a university owns various departments, and each department has a number of professors. If the university closes, the departments will no longer exist, but the professors in those departments will continue to exist. Therefore, a university can be seen as a composition of departments, whereas departments have an aggregation of professors. In addition, a professor could work in more than one department, but a department could not be part of more than one university. Composition is usually implemented such that an object contains another object. For example, in C++. In aggregation, the object may only contain a reference or pointer to the object. Sometimes aggregation is referred to as composition when the distinction between ordinary composition and aggregation is unimportant. The above code would transform into the following UML class diagram. Containment, composition that is used to store several instances of the composited data type is referred to as containment. Examples of such containers are arrays, linked lists, binary trees and associative arrays. In UML, containment is depicted with a multiplicity of 1 or 0n, indicating that the data type is composed of an unknown number of instances of the composited data type. Aggregation in COM. In Microsoft's component object model, aggregation means that an object exports, as if it were their owner, one or several interfaces of another object it owns. Formally, this is more similar to composition or encapsulation than aggregation. However, instead of implementing the exported interfaces by calling the interfaces of the owned object, the interfaces of the owned object themselves are exported. The owned object is responsible for assuring that methods of those interfaces inherited from unknown actually invoke the corresponding methods of the owner. This is to guarantee that the reference count of the owner is correct and all interfaces of the owner are accessible through the exported interface, while no other interfaces of the owned object are accessible. See also, C++ structure, composite type, composition over inheritance, has a, law of Demeter, implementation inheritance, inheritance semantics, virtual inheritance, references. General references, association, aggregation and composition, accessed in February 2009, Herald Station Paragraph RRLE, UML2, Addison Wesley 2005.